Hi everyone. This is a demonstration of the Circuit Repack tool, which is a part of the Cisco Way Network Catalog Function Pack for the WAN Automation Engine platform. Circuit Repack is a tool that analyzes circuit placement on multi-port line cards with two objectives in mind, including maximizing usable port density, as well as at the same time attempting to minimize the risk to your network of line card failures. Oftentimes, network operators, in an attempt to minimize the risk of line card failures, will be forced to spread circuits across many different multi-port line cards and not fully utilize the available port density that these multi-port line cards can support. This tool will use combinatory techniques as well as specific inputs provided by the user to analyze all possible combinations of circuits on a particular router in your network. Basically reshuffling the circuits and looking at every possible combination, attempting to find the optimal combination or set of combinations that minimizes the number of line cards needed to support those circuits, as well as minimizing the risk to your network of any of those line cards failing. The Circuit Repack bundle includes the documentation shown here on the right side of the screen. This includes a detailed explanation of the functionality of the tool, as well as the specific inputs required to run the tool. And it also goes through a sample plan file including all of the required inputs as well as the expected output that you'll see if you run the tool with these inputs and plan file. And we'll be going through the same sample plan file in this demo. Alright, so let's get started. This is a sample plan file that's included with the Circuit Repack bundle. It is a modified US WAN with additional circuits going into KCY. If we look at this specific site, we'll see that a lot of these circuits go into one particular router, CR1 KCY. We'll take a closer look at those interfaces by filtering on those. As we can see, there are 7 interfaces going into 7 different ports across 3 different line cards. So what we will attempt to do is analyze the combinations of these circuits on these multi-port line cards and try to come up with a combination that minimizes the number of line cards needed, while at the same time reducing and minimizing the risk of any of these line cards failing on your network. So first we will select all of these interfaces and then start up the tool. The first option here gives the tool more information about your line cards and the maximum number of interfaces that it can place on any particular line card. Here we'll give it a number. We'll give it a 4, which will tell it it can put up to 4 interfaces on a single line card for this analysis. Here we can select the specific interfaces that it is going to analyze. We selected that before we started up the tool by selecting those interfaces in the interfaces table. So those 7 are now selected. For this user input, you can set a specific max utilization network-wide that is acceptable during any single line card failure. What this will do is, as it's going through all of the combinations, as soon as it finds a candidate solution that meets this criteria, it will stop and provide that particular candidate solution. This can be useful for cases where you have lots of interfaces to analyze, and it may take a fairly long time to go through all of the possible combinations, and you know a particular max utilization is acceptable, so you can put this number in, and as soon as it finds a solution that meets that criteria, it will stop and provide that solution. If you leave it blank, it will go through every possible combination and provide you the candidates that are optimal, that reduce the number of line cards to the minimum number, and also provide the lowest max utilization for any of those line cards failing. If you have a large number of interfaces to analyze, you may want to increase the number of processors that this tool will use and attempt to parallelize the analysis and speed up the overall runtime of the tool. Here we'll leave that at 1. If you're attempting to analyze a large number of interfaces, again, you may want to look at interim results. What this will do is it will provide in the design log window a view of the best that the tool has found so far. So it gives you basically a running uh, um, look at the running results as it's going through, and gives you an idea of the best that it's found so far as it's going through all the possible combinations. This could be useful if you see over a long period of time that the tool does not seem to find any better candidates. You can stop it early and it will tell you the results that it's found so far. We'll look at that as we run the tool later on. Also, if you want to compare the results that it provides with your current Linecard SRLG performance, you can select this option, which will tell you the max utilization for any of your line cards in your current configuration. If any of these line cards were to fail, it will tell you the worst case worst case results of any of these line cards failing in your current configuration. So you can compare this as a baseline to whatever candidate solutions it comes up with. So we'll go ahead and run this. It will now go through and analyze all possible combinations and come up with a report detailing the results that it has come up with. Before we look at that, let's look at the log window so we can see what it looks like as it starts to churn through all the different results. So basically it just gives you the best solution so far as it's going through all of the possible combinations. So at first it found a set of combinations that provided 54% max utilization if any of the line cards were to fail, and it started providing all of the solutions that met that criteria, the best so far. And it lists them in terms of the indexes, and you can refer to those up at the top, which circuits those are referring to. So this is a combination of circuits, and all of these meet this best so far, 54%. And then later on we can see that it found a new set that is slightly better with 53% max utilization, and all of these are solutions that met that criteria. So it just gives you a running tally of what the best is so far. That again can be useful if you have a specific scenario where it might run for a long period of time. Alright, so we'll close that out and look at the final results that we found for this particular run. First, we look at what the baseline line card failure analysis is for this network. As we can see here, for the existing line cards, if the worst case is almost 55% max utilization if line card 1 were to fail, and it also includes unrouted demands. So we can treat that as a baseline to compare against any solution that it comes up with in an attempt to reduce the number of line cards used in your network for this router. So here we have a summary of the optimal solutions that it found. In this case, it found 12 possible solutions. Each of those solutions produce a 53% max utilization as a worst case if any of these line cards were to fail, which, as you'll notice, is better than what we have in our current configuration, which is 55%. But it has the added benefit of, instead of 3 line cards being utilized, it has repacked, reshuffled these circuits down into 2 line cards in each of these solutions, where one line card would support 4 circuits and the other line card would support 3 circuits. So it found 12 possible candidates that all produced the optimal result of 53% max utilization in your network if any of these line cards were to fail. So what this would allow you to do is rehome these circuits down into 2 line cards instead of 3, and take the third line card and use it elsewhere in your network where it is better utilized. That concludes the demo of the Circuit Repack tool. Please consult the documentation for more information about the functionality, or send general technical support questions to the Wave Function Pack Help email list. Thank you very much.